Okay, so the first method is the extended power rule, which mostly is used to integrate questions of this setup, x to the power n dx. So to integrate this setup, you add a 1 to the power and then divide the figure that you get, then you add a constant. So this is the easiest method that we use in integrating. The reason why we're adding a 1 is because integration is actually the reverse of differentiation. If, for example, if y is equal to x to the power n, then you're asked to, maybe let's say plus 7. Then you're asked to differentiate this. So you say dy dx is equal to n x n minus 1 plus 0. So now because of the minus and the multiplication, when you integrate, you have to add and divide. So we divide to take away this that was being multiplied, and then we add to bring back the one that was subtracted as we do the reverse. So if they ask me to integrate this dy dx, you integrate n x n minus 1 dx. So how do you integrate? Using this rule, you have x n minus 1, you add a 1 and then divide by n minus 1 plus a 1. And then you add a constant. So we have n x n over n plus c. So these n's can cancel, and so you get x to the power n plus c. Now we get plus c because really so many constants, when you differentiate them, they give us 0. So we may not know exactly that this one we're dealing with was 7 or it was anything, because even if y was xn plus 100, well, would have still gotten dy dx to be the same thing. Dy dx would have been the same thing. So that's why we put a c here, just to realize that, oh, there could be some constant that was differentiated and then they gave 0, even as we reverse this action. Okay, so just giving a reason as to why we are having the extended power rule in that. Okay, so let's do now examples coming from the Torah sheet. Question 1. Question 1, evaluate A, the integral of 10 x to the power 9 minus 12 x to the power 3 minus 5 dx. So now, how do we integrate such a setup? You use the same rule. So you say to integrate this, I'm just adding a 1 there, divide by the same, and then minus 12x 3 plus 1 over 3 plus 1 minus 5x plus a c. So if I find a constant 5, I know that for it to be 5, there was some x. And then now you just simplify. So we have 10 down here. 10 over 10, that is 1. So we just get x to the power 10 minus, this is 4 here into 12. We get 3x to the power 4. And then minus 5x plus c. That's the easiest that you can meet if you are to meet something of that nature. Then B, we have the integral and then dx. So this means that there's a 1 there. If I don't see anything, it means that there's a 1 here. And so I'm integrating a constant. So I'll have x plus c. That's all. Okay. What about I? The integral of 1 minus x multiplied by 2 plus x and then divide by x at the x. So in this setup, well, here we don't have the product rule. We don't have the quotient rule. So what do? You expand. So you have 1 in the numerator. We have 1 times 2. That will give us 2 plus 1 by x, we get x. And then negative x by 2, we get that, and then minus x squared. Everything we divide by x. And then the x. So now we'll start. The first one is 2 over x. The second one is x over x, which is 1. And then minus 2x over x, which is 2. And then minus x squared over x, that is just x. That is, I can write the 2 outside so that I have 1 over x, the x. And then 1 minus 2, I will get minus 1. Meaning we'll just have the x there, and then minus x, the x. So to integrate 1 over x, you can write it as x to the power negative 1. So if you try to add the 1, everything gets to 0 down. That won't work. So what do? You say, okay, because there's 1, you remember the derivative of the x. The derivative of this, you differentiate x and get 1, and then divide by x. So it means to reverse 1 over x, we just have to call back ln. So this is going to be ln x. But normally we put the absolute values here because we don't want it to be negative. So we do that. And then minus x squared over 2. And then you add a constant c. Like that. So you just take note of how you differentiate ln for you to be able to remember easy whenever you have a situation where you have the derivative in the numerator and the function in the denominator. Then you know I'm using ln here. Okay, then, and this was, we have some more I think we can pick from this question. Like h is 6 minus 2x squared dx. So this one you expand. So you have 36 minus 24x plus 4x squared dx. So after you expand, then now you integrate. So you have 36x minus 12x squared, and then plus 4 over 3 x to the power 3 plus c. Okay, so how has 24 become 12? Because we are doing 24 x squared over 2. So the 2 into 24 you get 12. Then what about 4 over 3? Because we have 4x squared, so when we add the 1 and divide by the same, you get 4x3 over 3. That's how we do the integration there. So that's how you do that. So in case you get a screenshot, oh, you have the screenshot there. Now, Okay. Then we go to, I think I'll leave this question just here.
So I'm not clear.
Can we ask the question?
I'm saying I'm not clear on how you found 12 the power.
So what we're integrating is, we're integrating 24x dx. So you say 24x, the power of x here is 1. So when you add the 1, it becomes 2. Then you divide by the same. So 2 into itself, it's 1. 2 into 24 is 12. And that's why we have 12x squared there. Then you talk of question 2. Question 2 is saying determine f of x given a, we are given f prime of x is equal to 16x4 minus 9x squared minus x. So for us to find f, if we're given the derivative, we integrate. So say f of x is going to be the integral of f prime of x dx. That is the integral of 16x4 minus 9x squared minus x dx. So how do we integrate 16x4? You're adding a 1 to the power, so we'll have 16x power 5 and then divide by 5. Minus, you're adding a 1 to 2, so it becomes 3. And then 9x3 over 3. 3 into 9 goes 3 times, so we'll have x to the power 3 minus x squared over 2 plus c. And all those questions there, B and C, are just depending on the extended power rule. So that's not a big case there. Okay, so we look at something that may be of good interest. Trig integration. So no, don't worry about how to find C or finding C. If C is to be found, you'll be given a point. And then if there'll be no such a question throughout, I'll look for a question that will help us get C so that you also see in case there is to be need. Okay, so first, before we integrate a trig, maybe we can recap on the derivatives. So I was saying the derivative of sine x is actually cos x. 1, 2, the derivative of cos x is minus sine x. 3, the derivative of tan x is sec squared x. And then 4, the derivative of sec x is tan sec. And the derivative of cosec x is minus cot cosec. And 6, the derivative of cot x is actually minus cosec squared. So we have 6 key main derivatives of these trigs. So every time you're integrating this trig, you should have in mind their derivatives for easy calculations. So that will mean that if we do the integrals now, we'll have the integral of sin x being negative cos plus c. The integral of cos x is now going to be sin x. Let's see. 3. The integral of sec squared is going to be tan x. And then 4, the integral of tan x sec x dx is going to be sec x plus c. And 5, the integral of minus cot x cosec x dx is going to be cosec x plus c. And 6, the integral of minus cosec squared x dx is then going to be cot x plus c. So you need to know these 6 derivatives and these 6 integrals. So once you know this, then we can easily answer the question that follows. So we answer the question now. We're doing question 3. Question 3, evaluate A, the integral of x squared. Sorry, I've gone to another. The integral of 6 sin x dx. Could be the wrong question. Minus 2 cos x. But this should be in brackets dx. So to integrate this, you can actually take out the constants if you want and remain with the integral of sin x dx minus 2, then the integral of cos x dx. And then you say, what's the integral of sine? The integral of sine, from what I'm doing here, is negative cos. So this will give us negative 6 cos x minus, what's the integral of cos? You check, the integral of cos is sine. So we're going to have minus 2 sin x plus the constant c. And then we go to b. We have the integral of sec x plus 7 sec x tan x dx. So we have that set up there. In fact, this here is supposed to be, sec squared x. Okay. So you can separate. You say the integral of sec squared x dx plus the integral of 7 sec x tan x dx. So what's the integral of sec squared? It's tan x. And then plus 7. What's the integral of sec tan? So if we check the integral of sec tan, the integral of sec tan is sec. So we just put sec here and then plus sec. So that's the solution there.
So,
Hello.
where we have on part A, where we have the integral cos being negative side. When the negatives multiply the negatives to give positive there.
No, the negative is just for the first part and not for the other part. This part here, we have maintained the -2 and just integrated cos to get sine. So negative is not impacting anything. Okay. We go to C. C has the integral of 6 cos x squared x minus 2 sec squared x dx. So here we get, again we separate. So say this is 6, the integral of cosec squared x dx minus 2, the integral of sec squared x dx. So that the integral of cosec squared, let's check. What's the integral of cosec squared? We had the integral of negative cosec. So this means that the integral of cosec squared is going to be negative quad, because you can divide the negative the other side. So that here we'll have -6 and then cot x, and then the integral of sec squared, that is tan. And then you just add the c. So the whole question 3 is answered just by this page here. Okay. Then what else?
Uyu mwana uyu toni choka kaidi.
So let's do another one. The integral of exponent. The integral of exponentials, a recap. When I say a recap, we are going back to the derivatives. If you are given e to the power g of x, and you want to differentiate this, you differentiate g first, and then multiply by e to the power g of x. Okay, so that's how you differentiate. So, meaning that to integrate, you should think of dividing something here. Okay, that's one. Two, to integrate a and to differentiate a to the power g, you would get the derivative. You have a g of x multiplied by the derivative of g, then multiplied by ln of the constant. So now you know to integrate this, you have to integrate this, there will be some kind of division again needed here. Okay, from this. So let's see if we can get in general. So one, how then do we integrate e to the power x dx? So this e to the power x dx comes from an integral of itself. So if you have to differentiate e to the power x, you get e to the power x. So it means that we just have e to the power x plus c when there is e. Okay. What about if so this side I'll be putting, hello?
I didn't get that part.
So if we give you the function y is equal to e to the power x and ask you to differentiate it, what do we get? We get e to the power x. Because we are saying you differentiate the power and then multiply by the function. When you differentiate the power x, you get 1. So multiply by ex, you get ax. But to integrate the ex, if it's the derivative of itself, it must be the integral of itself. Okay, so this means that if I'm to give the general integral of e to the power u du, then we are saying, well, the integral of this guy is going to be eu over the u prime plus c, provided that the u prime is a constant. Provided that the u prime is a constant. That's a general case. Let's see if you can understand it here on question 4a. The integral of x squared plus 2e multiplied by x dx. So first, to integrate x squared, you just do x3 over 3 plus 2 to integrate ex, you just have the ex itself plus c. Maybe this was too easy. Let's try b, the integral of ex again plus 2 over x dx. This one, you say, well, I'm integrating ex, I'll get ex itself, plus to integrate 1 over x, remember we said you get to ln. So you have 2 multiplied by ln x. And then you add this.
Excuse me, sir.
Hello.
So for this one, when you're given a power, which is a variable, we're not adding 1.
No, we don't add it.
All right.
It's like when you go back to the signs, We're not adding a 1 to integrate sine, is it?
Yes.
We're just saying the integral of sine is cos. So it means that there
Yes.
are types of functions where you don't have to add a 1.
Oh, okay.
Yes.
All right. Thank you.
Okay, so what else is here? A bit of some exponentials on them.
So repeat this one. Number B. I get it.
So number B, the integral of 1 over x. We have said the integral of this setup is ln x plus c. So if there's a constant on top, then you just take away the constant. So like there was a 2, so we're dealing with 2 and this, the x. So it was 2 ln x plus c. What if, there's a question, what if 2 over x had a power? Well, then it means you have to use a different method. If you had the integral of 2 over x to the power 3, then this is the same thing as the integral of 8 multiplied by x to the power -3 dx. So it becomes extended power rule. You change the methods if you have such a setup. Okay, so I was just heating up today, so you could see how we're learning here. And this is how we proceed. So tomorrow we'll finish up this integration thing. And then over the weekend we start, no, there's physics test. So on Monday, we'll start revising now using past papers. So there are past papers that are to be used, not in past papers anyhow. So I'll give a guide on Monday on how we use past papers and why we should use past papers. Not that they're the ones that are coming, but why we should use them and how. So we end here today. I will upload the video in the group. Here you all clear, don't worry.
Sir,
Hello.
before we end, what if on B there? What if it was x over 2
It becomes x squared over 4.
instead of 2 over x there?
It becomes x squared over 4.